So the way I think of point source pollution is that I can point to the source, literally. So if I see a pipe of something going into a water body, do I know who is the source of that pipe? So for example, here we have a pipe that I don't know what it's releasing. Probably something not great. I mean, you see all this white stuff around it. But I know exactly whose pollution that is. It's this company. This company is releasing something into the environment, and this is their pollution. So the Clean Water Act can regulate that company and say, hey, we know you're releasing water into the environment. It needs to do this, it needs to do this, it needs to do this. So that's what I mean by point source. Here's another example. This is actually looking at a wastewater treatment plant. Remember I said those wastewater treatment plants have so many standards on them? Well, this one has, it's not really a pipe, it's kind of an outfall system. But again, I see this water entering the environment and I can point to that source. The source is a wastewater treatment plant. So me, the EPA, I can regulate that wastewater treatment plant and say, hey, if you're going to put that water in the environment, it needs to have this, this, and this. In another lecture, we'll take a look at the other type of pollution, which is non-point source. But the Clean Water Act is really looking at point source pollution because they can regulate it. They can say, hey, you're the company making this pollution. Here's what you need to do. So what kind of things are they regulating? What kind of things are being monitored and being looked after? So probably the most obvious one, and probably the one that you are thinking the most, is just chemicals. What is in that water? Is it toxic? Is it mercury? Is it going to bioaccumulate? Is it going to biomagnify? So hundreds of different chemicals are regulated under the Clean Water Act. It's mainly heavy metals such as mercury and lead and copper, mainly because those are the most toxic. But things like pesticides are also monitored. Things like chlorine are also monitored. So there's tons of different chemicals that we know can harm the environment or even harm people who might be swimming in that environment or using that water for recreation or fishing, etc. So this is probably the most obvious one, just thinking about chemicals. So let's dive into some others. You might not have ever thought of sediment, dirt, being a pollutant, but it totally can be. I mean, imagine you're a fish that's living in clean fresh water, and then all of a sudden it's so murky so you can't find your food, or whether it's grasses, whether it's algae, whether you're looking for other fish. But also, if it's really, really murky, that means there's not a lot of sunlight. And so those photosynthesizers, those producers in those ecosystems can't produce. And so you might actually kill that ecosystem from the bottom because those producers can't really exist anymore. So sediment is definitely a big pollutant. Now, sediment isn't from, I mean, it can be from a dirt pile in your yard, but typically construction sites. And so if we look here in the background, we have this house or building that's being constructed. And what usually happens at construction sites is they chop down all the trees, and because there's so much equipment and machinery, a lot of the grass wears away and just leaves bare soil out. Well, when it rains, like what's happening in this picture, that rain is bringing that soil with it. The soil is just washing away. And that's where we get the sediment pollution. However, because of the Clean Water Act, construction sites actually have to get a permit and say, yes, we are going to take care of this sediment. So what you may have seen before, but maybe not realize why it was there, you may have seen these guards over stormwater drains. You may have seen these little black fence type things around construction sites. The whole purpose of those is to prevent sediment from washing away. Now with that in mind, if you see one of these that is broken or misplaced or missing, definitely contact the county. Call 311. Tell them, hey, here's this construction site and like part of their fence is broken. I know you don't want to be a tattletale or anything like that, but it's so critically important for our environment. And depending on how long it's been missing, you know, maybe they don't even know or they didn't notice. And that's kind of where your job is as a citizen, to kind of speak up and just say like, hey, there's, you know, something wrong with this fence. Like, can it get fixed? Because you rely on those freshwater resources too. Another thing that gets monitored by the Clean Water Act is looking at those nutrients. And we've talked about nutrients quite a lot, that nitrogen and phosphorus and potassium. We've talked about it with agriculture. Agriculture is kind of a separate issue because agriculture is technically not a point source polluter. So we'll talk about that more in our next unit or next lecture. But the nutrients that I'm referring to is actually nutrients that you and I actually contribute into our wastewater. So the source of that is food. Now, not the food itself, but when we eat it, obviously we excrete it, whether it's because we're peeing or pooping it, but also food scraps. If you aren't composting your food scraps and you're not throwing it away, maybe you're a big garbage disposal person. Well, that broccoli, that pepper, that onion, that had nutrients in it, and now you just put it in the wastewater. So it's a huge source of nutrients. Human waste, huge source of nutrients. Whatever our body didn't use, we just get rid of it. Also things like soaps, whether it's dishwasher detergent, whether it's laundry detergent, even hand soap actually has nutrients in it as well. Phosphorus, which is found in these soaps, is really, really great at getting stains out. So that's why we use it. But obviously, when our washing machine drains, that water goes somewhere and all those nutrients go somewhere. So we are actually contributing to nutrient pollution because although a wastewater treatment plant can remove a lot of it, it doesn't remove all of it. So the less that we can contribute, the better. The kind of last one that we'll talk about is temperature. Temperature is kind of a weird one because you don't think of temperature as an actual physical thing. You think of temperature as a condition, but even temperature is regulated. So in this picture, you may have seen these before. We don't really have them here in Montgomery County, but you may have driven somewhere and seen these. And when people see these, they usually look at all this smoke coming out and they're like, well, that's not good. But it's actually fine. That is actually all water. Obviously in the form of steam. So this is actually steam being released. So coal-powered plants, nuclear power plants, a lot of actually energy generation plants use water. The reason they use water is that whatever their energy source is, whether it's trash or coal or oil or nuclear reactor, they all use that energy source to boil water. And then that steam from that boiled water is used to turn a turbine, which is used to generate electricity. But that water came from the environment. And that's why usually these plants are on a river, which you can see right here. So they take in water. They don't actually use it. They don't mix it with anything. They literally just take in the water to boil it, turn it into steam. The steam goes through. But then the issue is now we have this really hot water that we want to return to the environment. Well, that water's really, really freaking hot. If it's so hot, you can't just return it to the environment because it has the potential to kill a lot of organisms. You can't just introduce a very huge temperature gradient and organisms be okay with it. Some organisms are, but some organisms can literally die from the shock of a temperature change. So the whole point of those towers is literally to cool down that water. What you might not have known, the inside of these are hollow. And there's these hoses and sprinklers that run all up and down these towers. And what they do is they spray that really hot water. This is a really bad picture, I realize that. They spray all of this really hot water into the inside of this tower. And there's air circulating through this tower. It's actually open down here. You can kind of see these triangles, but that's actually all open. And so there's an air current that's spinning around through here. And as that air is spinning around, it's helping to cool that water that's being sprayed into the middle of the tower. As that water falls, some of the steam is released. That's what we're seeing in this picture. And the cooler water sinks back down and then gets released back into the environment. So again, the whole reason for that, the whole reason these towers exist is because of the Clean Water Act. Because we were seeing the negative impacts of temperature on the environment. So go ahead and pause here. A very, very quick video that is just showing you the inside of these towers. So when you watch the video, try to imagine this process happening inside that tower now that you have a better visual. So go ahead and pause here, click the link to this video and then come back. The last thing that we'll talk about that the Clean Water Act is regulating in our water bodies is trash. Kind of. The Clean Water Act does not force any states to actually have trash listed as a pollutant. However, the Clean Water Act also does not discourage states from doing it. Trash is just a weird issue because trash comes from so many different places. So the Clean Water Act doesn't say you can't do it, but doesn't say you have to do it. However, there's a lot of states and a lot of water bodies that actually have, as part of their cleanup and pollutant plan, trash actually listed. They might have temperature listed and chlorine listed and nutrients listed, but they'll also list trash. And the big issue with trash is particularly plastic trash. Paper will dissolve. Cardboard will dissolve. Metals, really not a common trash item because a lot of people recycle those, but plastic is a huge issue because plastic is everywhere in our society, and it also doesn't break down. It can take, depending on the plastic item, it can take anywhere from 10 years to 1,000 years to break down a piece of plastic. So if it gets into the environment, it's not like, oh, it'll dissolve in a little bit or it'll break down. Yeah, it will, but it might be hundreds of years before that plastic item vanishes. And even when it vanishes, it's not actually vanishing. It just broke down into smaller pieces. And so when plastics get into the environment, they actually have a huge impact, particularly with marine life. We'll talk about why marine life are affected so much in a little bit. Well, if we take a look at this, here's that plastic rings around a 6-pack of soda. And this turtle might have gotten caught in it when it was a much smaller turtle, and the turtle started growing and growing. But if you guys have ever tried to break those with your hands, you know that's impossible. So literally this turtle grew around this plastic ring. So it probably has a lot of internal issues. They might have decreased lung function. They might have, issues with digestion. Here's a seal or a sea lion that ended up starving because they got this plastic ring stuck around their snout. They couldn't eat, and they couldn't get it off. It was just stuck. This plastic wasn't generated by the environment. This plastic was generated by us. This plastic was put into the environment by us. We are the sole problem. It's not companies doing this. This is literally humanity doing this. And so it's kind of a big issue. And I really mean big issue. In the world, we have these things called garbage patches. And I'm not talking about landfills. In the ocean, there are multiple garbage patches. One of them, I'm pretty sure it's the East Pacific garbage patch, is about the size of Texas. It's a part of the ocean that has so many plastics in it. And it's trash in general. That's why they call it a garbage patch. But a majority of it is plastic because that plastic is just not breaking down. Now, I will say these are typically microplastics. Microplastics are just if you had that plastic bag and it broke down, the plastic's still there, it's just really small particles. So it's not like you're going to drive your boat and it's like, wow, here's the whole state of Texas in trash. You wouldn't really notice it unless you're taking cups of water and actually pulling it out and be like, wow, there's a lot of stuff in here. That stuff is actually microplastics. So this is a huge issue. And again, this isn't companies doing it. Temperature is kind of like, okay, well, that's a that's a nuclear power plant doing that. Or, oh, nutrients, well, that's a wastewater treatment plant. This plastic pollution is literally our fault. We're the ones using them. We're the ones not disposing of them correctly. So this is actually the end of this lecture, but I'll go ahead and introduce the video. The video that you're going to be looking at is at Midway Island. So Midway Island is in the middle of the Pacific, and it is an island of trash, but no one lives there. And the reason there's so much trash there is that what you're seeing is these currents. The currents are what are making these garbage patches. They're taking all the trash from around the world, and they're getting stuck in these currents. Well, Midway Island happens to be along one of these currents, and so a lot of plastic just ends up washing up on this island. And this video kind of shows you some of the consequences of that happening. So this is where the video ends. I still have this link popping up, but it's also in the weekly guide. So go ahead and check it out, answer the follow-up questions in the weekly guide, and I'll see you guys for the next lecture.